Hello, welcome and good evening to the next episode of Let's Code MS-DOS. And last time we did this, we wrote a little Pong style game with VGA graphics, keyboard input and the likes. Now in the second season, so to speak, I wanna tackle some more tasks that you need if you wanna write MS-DOS applications and games. And my goal is to put out like 1 or 2 videos every month. Some of the topics are rather advanced, so I will need a bit of preparation for that. So bear with me. If you want to help the channel out, then please consider subscribing and or drop a coin into the Ko-Fi or Patreon account. I've set up those to help with some expenses that I have regarding this hobby, and while this is just a hobby, it would be nice to get something to make further interesting videos. So if you like to do that, I would be very grateful. So this week we want to do some coding for the mouse, and I've set up a simple program here that is basically the skeleton of our VGA based game, and our main function does nothing except for setting the graphics mode, blanking the screen, and then handling the input, waiting for the escape key, and limiting it to the refresh rate of the screen, which is 70 Hz, and then setting the text mode if handle input says OK, escape was pressed, and then just returning. So, as for the mouse is something that came later in the PC's life. The PC was created in 1981, and the first mice took a couple of years to arrive on the scene. And there were different standards for MS-DOS, but the most widespread standard was basically the Microsoft mouse, and the Microsoft mouse driver that you had to install provided us with an API similar to the one that we have for the graphics. The API in DOS is always an interrupt, so the interrupt 33 hex is the mouse function calls, and today we only need 3 of those. The function 0, which is resetting the mouse and determining if a mouse driver is installed, the show mouse cursor, the hide mouse cursor, which is basically almost the same, very simple functions, and the get mouse position and button status. So let's get started by defining some constants here for the mouse input. And first of all, we will define the mouse interrupt, which is hexadecimal 33, and we define the different functions. Mouse, let's call it UnitMouse so we don't confuse it with the mouse interrupt, and also the show mouse, which is function number 1, hide mouse, which is function number 2, and get mouse status, which I'll keep short. Let's be verbose, I would say, it's probably better, which is function number 3. So let's first look at the get mouse function. Basically you only have to set the AX register to 0, and when calling the interrupt 33, AX will be still set to 0 if there's no mouse driver installed, or quadruple F if the mouse driver was installed. In the BX register you can also query the number of buttons. Usually those would be 2 or 3 under DOS. Back then there was no scroll wheel, no extra buttons. You had 2 or 3 mouse buttons, and the Microsoft mice usually had 2 mouse buttons, so only very few programs dealt with a middle mouse button, which most users did not have. So I think we should write a UnitMouse function then. So the UnitMouse function will look something like this, and we probably want to return a value if there was a mouse or not. And what we need is a set of registers, just like above, and then we set the AX register to UnitMouse. Then we call the mouse interrupt, mouse int, and pass the registers as usual, input registers, output registers. Don't forget the ampersand for taking the address. And then we return 1 by comparing F to, let's do it like this, by equal to the current register AX. So this will return 1 if a mouse is installed and 0 if there's none installed. So we can go down to the section here. If UnitMouse, if not UnitMouse, then we will print something like no mouse found. And we can quit. So this should hopefully run, and it will do nothing because we have a mouse. But if we take away the dot, the exclamation mark, we will have a very quickly exiting screen, and it says no mouse found, which is of course not true, but that way we can check that the function actually returns the correct value. Okay, so the mouse is initialized. Now we want to show the mouse cursor. This is a simple function. This is a very simple function. Show mouse cursor is just x equals 1 without anything else. So we can more or less copy this whole function, and we don't need to return anything. And we will call it show mouse, and this was the same, show mouse, and let's do the hide mouse as well, because it's very simple and very similar. To the show mouse function, hide mouse. There you have it. And we can already test this. After setting and blanking, we can call show mouse. And to be nice, we will call hide mouse before going back to text mode. And let's see if that works. And there you have it. The mouse driver comes with a built-in mouse pointer or mouse cursor, and we can already move it around. That's pretty nice. You can even set your own graphics cursor if you don't like the default one, but we won't do that in this episode because it will take too long. But you can basically look at the API and supply your own screen and cursor mask. Cursor mask means the transparent parts, and it's basically just a bitmap. Yeah, so we can show and hide. Now we want to do something useful. We want to get the position of the mouse cursor and draw a pixel. That would be nice, so we make a little drawing program. So we want a function GetMouse where we pass an integer variable to get the x and y coordinate, as well as the status of the left button and the status of the right button. So the idea will be that we can set a color with the left button and erase it with the right button. So what do we need to do? The same as before. Call the mouse interrupt, this time with the GetMouse status function. GetMouse status. And now we need to do a little bit more. So the x value is stored. Let's take a look. We call the mouse button, and register cx will have the horizontal position and bx the vertical position. Note the value range here is 640 by 200, which is CGA resolution, and this is always the case, so you don't get any higher with the standard mouse interface. If you have higher resolutions, this won't probably be happening, and especially in our 320 by 200 mode, we will still get the 640. So we need to divide the x position by 2. Rex cx, I think it was right. Yes, cx divided by 2. And don't forget to put the asterisk here to dereference the pointer that we get here, because C doesn't have the C++ style references basically. So we need to do it like this, and the y coordinate is rex x dx, and we don't need to do anything here. So this will give us x and y. And now how to get the left mouse button. So we get in bx the button status, and bits 0 and 1 are the left button and the right button. So rex x bx bitwise and with 1 will give us the first or 0th bit of the left button, and rex x bx and 2 will give us the second or number 1 bit here for the right button. So that's pretty good. We can already get everything that we need. Now we need to implement something for drawing. And for that we will define two colors. Black is always 0x0 in the default palette. And let's start with white. White is 0xf in the default palette, or if you want to write it as a byte, something like this. Then we need to store exactly these four things, x, y, left and right, and also store the current color, and we'll set that to white in the beginning. And that should be actually a byte. And now, what do we need to change here as well? So, first of all, we will call GetMouse status, or GetMouse, call it. Give the addresses of all our variables, like this. This way we get the status, and then if the left button was clicked, we will try to set, was it set pix? We defined that up here somewhere. Yeah, set pix, x, y, and color. So set pix, x, y, and current color. And this is basically just poking into the video memory. The right button will be X, Y, and black. Black will always be erasing. So this should already give us some kind of control. But if we try this out, okay, we have some typos. Invalid indirection, yes. Let me think, what did we do wrong here? Oh yes, because we forgot to add the asterisk back, and this already helps. So if we try this, you will see the button, when I press the button there will be a white pixel, but as soon as I move the mouse it will disappear. And this is because we're just poking into the video memory. And the mouse driver works in the following way. It will store whatever is under the mouse cursor, then draw the mouse cursor, and when we move the mouse it will restore whatever was before. So whenever I click, I put a pixel there, but it gets erased by the mouse driver. So the simplest thing that we can do, and since we are aligned with the vertical refresh, this will actually not flicker. We can do the following. Every time we see that a button click happened, we can hide the mouse cursor and then afterwards show the mouse cursor again. This way it will restore what's on the screen, then we set the pixel and then it will store again. And this should work just fine. Same goes for when drawing black. And if we try that, we can draw stuff. And when I draw faster, you can see that the sampling rate of the mouse is of course not continuous, but is limited. But if I draw very slowly, I can actually draw stuff or write something. And this is already pretty nice. And as a bonus, we will add a bit of color to this. And instead of just drawing dots, you can of course draw lines. But that's something that we'll talk about some other time, of course, because drawing lines is a bit more difficult. And that will take another episode. So let's add some color to make it more nice. For that, we add a key handling. Let's say I press the plus key, then I will take current color and increment it by 1. Then break, of course. And the same goes for minus. Then I will simply decrement the current color. And that should already be enough to get some color in there. So right now I can draw white. If I press minus, we'll go to yellow, then magenta, red, light blue, light green, dark blue, gray, white. And right mouse button will it work actually? Yes, it kind of works. It's hard to hit the right spots. And if I just keep on holding the minus key, I will draw a nice rainbow. So there you have it, a very primitive drawing program with mouse handling. Not being able to save or load anything, file handling will come at a later point if you're interested in that as well. But you can see you can already write your own MS-DOS paint program with mouse support. Yeah, I will put up, as usual, the code on GitHub, link in the video description. And if you want to learn more stuff like this, make sure that you watch all the previous videos and hit the subscribe button. Leave a comment if you want to, like or dislike if you liked or didn't like the video. And I hope to see you soon. Good evening.